Today we're going to speak about the geometrical series. Remember the word series, which means the sum of any sequence. So today we're going to take the geometrical sequence and add them together. Geometrical series is the expression formed by adding the terms of a geometrical sequence, provided my r is not equal to 0, and we'll see now equal to 1, and we'll see now why is it not equal to 1. The rule says a1 multiplied by 1 minus rn over 1 minus r, and that's why we said my r is not going to be equal to 1, because if it does equal to 1, then I'm going to divide by 0, then this whole thing is not going to be existing, because I cannot divide by 0. Let me have an example. Find the sum of the first 10 terms of the geometrical sequence. Example 1. Negative 3 plus 6, negative 12 plus 24. Remember, even though you have a negative and then a positive, that does not mean it is not addition. It is addition, but my terms are alternating between negative and positive. My first term, which is a1, which is negative 3. What about my r? How can I get my r? I'm going to divide 6 divided by negative 3. 6 over negative 3. Negative 12 over 6, or 24 over negative 12. All of them would give me the same answer, which is negative 2. Now, let's plug in this rule. a1, which is negative 3. 1 minus r, which is negative 2, and don't forget to put it between brackets. And then to the power 10. Why 10? Because he said the first 10 terms. And then divided by 1 minus 2. So it becomes 1 plus 2, which means 3. Minus 3, bracket, 1 minus 1, 0, 2, 3. We multiply the minus together, we get the 5, and simplify the 3 with the 3, we get 1, 0, 2, 3. Can we solve this example in another way? Yes, we can. It's the same example exactly. Negative 3 plus 6, negative 12 plus 24, and so on up to 10 to the third. I can do that using my summation notation. If I forgot the rule and I don't know what to do, I'll try and work it out using summation notation. I know there are 10 terms. I know that my n is when I'm starting from the first term. I know that I can get a rule for that by using a1 r to the power of n minus 1. I'm using this one. So this is my rule. Minus 3 minus 2 to the power of n minus 1. And then somebody would ask, but we do have an n here. Okay, for the first term, what are you going to do? We're going to have 1 minus 1, so it becomes 0. Anything to the power of 0 is 1. So that's why it will end up with 1 times minus 3 becomes minus 3. Okay, so that's my rule, and then I'm going to have the same answer. Now, example 3. Assuming I do have the sum, but I don't know how many terms are there. I don't know the r. I know Sn equal 86 for the series 2, minus 4, 8, and minus 16. And I do know that a1 equal r, which is minus 2. Okay? And I don't know how many terms do I need to get. I don't know the n. I know this sum is S of n. But how many numbers do I have? How many terms in my sequence in my series must I add? I'm going to plug in what I have. a1 is 2. The r, I got it by dividing minus 4 over 2, which is minus 2. 8 over minus 4, which is also minus 2. So minus 2 is my common ratio. R equal negative 2. To the power n over 1 minus 2. So I get 43 after dividing both parties by 2. I'm going to have 43 equal 1 minus negative 2 to the power of n over 3. Now, I'm going to multiply by 3 to get rid of this 3. Multiply both parties by 3. I'm going to have 129 equal 1 minus 2 to the power of n. Take the 1 to the other side, it becomes 128 equal negative 2 to the power of n. So what am I going to do? I'm going to search for something to the power of negative n, and it has to be negative, of course, because I need my negative sign to be multiplied with this negative sign outside to form a positive sign, which is 128. Okay, so I'm going to see, okay, this is my 128. I'm going to try and cancel or simplify. Divided by 2, I get 64, 32, 16, 8, 4, 2, and 1. How many 2's are those? 1, 2, 3, 4, 5, 6, 7. So to get a 128, I need to have 2 to the power of 7. And I know it is negative, so negative 2 to the power of 7 would be equal to negative 128 multiplied by this negative. I get the positive 128. So the number of terms I'm going to have is 7 terms.